And this configuration and word of mouth considering like crypto settings among admins is like very widespread. Some people use very bad defaults that are shipped by their Linux distribution or shipped by their unupdated Windows operating system or whatever. So, a short recap. There's different mail protocols running on different ports. Most of you probably know this, but I'm just going to tell this again because there's like many different ports that I'm going to mention. So, port 25 is LTP doing start TLS. So, what you do, I'm going to give a detailed graphic afterwards as well. You connect to the email server and tell it start TLS, and then it inbound upgrades to an encrypted connection. This is like the method called start TLS. Start TLS is not a general way to do something. It's very specific to the protocol. So start TLS has to be specified for each of these protocols independently like that. Another way to do TLS handshake with, for example, an SMTP server is implicitly. So on port 465, you can just open a TLS connection right away, and you will it's called SMTPS, and you will get to the email submission and the same protocol as well, but without start TLS. The same works for IMAP and Popo. Are there any questions about this? I know this is like really easy stuff, but if you're not like an administrator and doing this regularly, you might notice some of these ports, but not all of them. Okay. This is like the typical flow. A user submits a mail, either on port 25, 600, 465, or 587. Either implicitly or with start TLS, user submits it to a mail submission agent. The mail submission agent then relays the traffic to a mail transfer agent, which is usually the next server in the line. This server redirects to next server in the line. So big universal setup sometimes have 6 or 7 redirects because they're very complicated email setup. In the end, it's going to be delivered to the mail delivery agent, which is of course a server, but the user can pick up his email, like for example via POP or IMAP. I hope this is clear. This is how start TLS and SMTP look like. And that's more detailed. So basically you do trigger TCP handshake, afterwards you get a message by the server that says, hey, I'm here, this is my domain. You send it a message saying, okay, I want to start a start TLS. I want to start a connection. My email address is something with example.com. Then the server responds to you what kind of features it offers. And if it has the feature start TLS in there, you just send it a message called start TLS. You get back a message that says go ahead. Actually, it doesn't even have to say go ahead, it just have to say 2020. And then it will invent TLS handshake. So that's basically the whole TLS protocol as an invent upgrade in SMTP. So my client hello server, key exchange. If you have detailed questions about how like TLS works and how key exchange works, I might later in this email and I can give you an introduction there. I did a workshop last year on TLS with like the Better Crypto project explaining this. So I still have slides if people are interested, but most people just find this amazingly boring. The methodology we use for like collecting all this stuff, we of course get the entire PV4 space. There's currently no IPv6 scanner, of course. We use mask and not CMAP, and we have it customized SSL layers, thanks to Willy, and with the queuing framework right in QRun. We did about 10 billion TLS handshakes over a couple of months. So if you look at the server on the internet, you will see mail logs with scan.spa-research.org, that's us, and some of you maybe even answer this. So what does SSLS do? SSLS basically opens a lot of TLS connections on different ports, like the ones you specify, and it asks, do you accept a certain cycle suite? For example, AES. It says the server might return no, and you will ask for another cycle suite. If it returns yes, you know this, and then go on with the next cycle suite. This is very obvious, right? It's just an enumeration of cycle suite. So very easy. as well as it's multi-threaded and parallel, so you can spread out the work and it performs quite well. We used two different input data sets. We first used scan-silo data that was collected previously by the University of Michigan people and I guess Rapid and other people. We later went on to do our own discovery scans and certificate collection with Muslim. We did pre-processing, a cytosweet scan, which was then created to our scanning server, post-processing, and we analyzed all of our results in Google BigQuery, should say. But, yeah. So Google BigQuery is rather nice. It's a big data analysis framework, and it's pretty cheap versus like setting up our own cluster for analysis. So typical scan flow would be having an input data set of IP addresses, doing pre-processing, doing a cytosweet scan, and then post-processing all of the data sets you get back, and push it into a database. For example, we first used Postgres, and later we used BigQuery. So in detail, this was like this. We have a revenue queuing system that talks with SSLIs, gets targets, and writes them to XML files. These are getting compressed, tagged, and moved over to other servers to be converted and analyzed. We get a resulting JSON file, and we put all of this into Google BigQuery, and from Google BigQuery we can extract this schema, of course. If you're really interested in the details, you can talk afterwards, but I mean, it's like a very simple